For concave mirrors. We looked at concave mirrors yesterday. We saw how to draw the ray diagrams to figure out where the location of the image is going to be, and we could see how big it's going to be and all that. Today we're going to be looking at an equation that will tell us where the image is, and we will do a little lab where we actually shine the image onto a piece of paper and take the measurements. Yes?
Was there homework yesterday? Because there wasn't anything on Schoology.
There wasn't anything on Schoology. I will have to take a look at that. I think that I put it on during lunchtime or something like that. So we'll take a look at that. Purpose: I will learn how to calculate and find the curvature of a concave mirror. This applies to satellite dishes and telescopes. You'll be a success when you can calculate the curvature of a mirror in two ways. Then I will compare the two results. When given the location of an object and the curvature of a mirror, I'll be able to calculate the location of the image. So one equation will allow you to do all those calculations. If you want to look at this on YouTube, you can see that. Let's see, due tonight, it's not homework 119, it is homework 124. The next quiz is on day 127, if I remember correctly. The curvature of a mirror is measured by the focal length. The more curved it is, the smaller the focal length is. Remember that rays parallel to the axis are reflected through the focal point, which is where the focal length is measured. To relate this curvature, this focal length, and the image distance and the object distance, we have an equation that we affectionately call Fidoti. It's 1 over f equals 1 over do plus 1 over di. Fidoti. The f is the focal length. The do is the object distance, how far the object is from the mirror. And the I is the image distance. You can measure them in centimeters if you want, or in inches, or in meters. In other equations we had in the past, we had to be picky and make sure that everything was in meters. Not so in this equation. And let's look at the other equations we have this chapter. Okay, for these equations here, we needed them to be in meters. So I can't say that the entire semester is irrelevant. It's this equation. Okay, number 4. A concave mirror has a focal length of 20 centimeters. Find the image location if the object is placed 30 centimeters from it. So 1 over f equals 1 over do plus 1 over di. The f is 20. So 1 over 20 equals 1 over, the object is 30, plus 1 over di. The answer is not 50. We have to do all that yucky stuff with common denominators and getting fractions and all that kind of stuff. There's an easy way and there's a harder way. For me, personally, I find it easiest to turn everything into decimals. So 1 over 20, 1 divided by 20 is 0.05. 1 divided by 30, 0.033. Plus 1 over di. Subtract 0.033 from both sides. 0.05 minus 0.033. 0.017 is equal to 1 over di. Now notice this is 1 over di. We want just plain old di. So we have to flippity-flop both sides. We can think of this as 0.017 over 1 if you want. So flippity-flop both sides, it's going to be 1 over 1 over 0.017 equals di over 1. And now I can do that division. 1 divided by 0.017. And I get 58.8. If you just simply said 59, that'd be fine. Don't forget to flippity-flop the final step. You have to have plain old DI, not 1 over DI. A lot of people stop at this stage right here. That's wrong. A concave mirror has a focal length of 40 centimeters. Find the object's location if the image is found to be 50 centimeters from it. 1 over F equals 1 over DO plus 1 over DI. 1 over F is 1 over 40. We want to find the object distance, so that stays a letter. The image distance is 50 centimeters. That's DO. We're trying to find the object's location. So 1 over 40. That's 0.025. 1 over DO stays a letter. 1 over 50. 0.02. Subtract off 0.02 from both sides. Get 0.005. Then we have to flippity-flop. 1 over 0.005 is equal to DO. 1 divided by 0.005. 200. How's that go? Does that feel all right? Not too tough? Go ahead and do numbers 6 and 7 on your own. When you're done, please confirm with your neighbor that they got it right. Help them out if they got it wrong. I will work it out here as well. There are my two answers. Did I goof? Any questions? How many people had at least one of them right? Not many. Go back. Anybody else need more time? 4.4. Okay, so here we have some uses of concave mirrors. These are not mirrors of light, but rather mirrors of other kinds of waves. Please put away your phones at this time. Close up your laptops. So here, this is before the days of radar. They had these, just like whisper dishes, to listen for the incoming airplanes from Germany. So somebody would stand right here where this pole is, have their ear next to there, just stand there listening. And if they hear the rumble of an engine, they would get on their motorcycle or whatever, and off they go. Or maybe they'd have a walkie-talkie. I don't know if they had walkie-talkies back in World War I. I don't think so. But they'd have motorcycles or cars, and they'd go and they'd warn the nearby airport. Okay, here's a whisper dish just like we have. Satellite dishes, that's the nubbin right there that actually detects the satellite signal, but it's capturing all of the signal that hits the dish, and it's focused and concentrated right to that spot at the focal point. Football players get their grunts and groans recorded by something like that, same way. And then with astronomy, stars give off not just light, but also all sorts of radiation, ultraviolet, infrared, microwave, X-rays, gamma rays, all of those kinds of things. So here's a giant concave mirror. It's about the size of a football field, or maybe even more. Okay. Some telescopes work with concave mirrors. They're called, I believe, reflecting telescopes is the name of them. And so we can see how these rays that are basically parallel coming in from the star get bent so that they appear to be coming from a larger angle, and that makes it magnified. Okay, concave lab. That'll be the next thing, and we do have some analysis questions on Schoology. And then you'll have I believe there's a homework assignment as well. Maybe this is just the homework itself. Check out on Schoology to see in folder 124 what is there.